Forget the giants, the true source of fuel is microscopic. The common story involves massive ferns and dinosaurs. But that narrative misses the essential, unseen foundation. But the real engine of energy formation lies beneath the waves. For eons, the oceans were teeming with microscopic life. Phytoplankton, the ocean's primary producers, harness solar energy. They convert sunlight into organic matter with incredible efficiency. This single-celled biomass forms the base of the entire food web. And now that we understand the source, let's explore the burial process. When these tiny organisms die, they begin their long descent. In oxygen-starved deep waters, preservation becomes possible. This settling organic ooze mixes with fine clay particles. Over millions of years, layer upon layer buries this rich organic soup. Heat and immense pressure act as nature's industrial cooker. And the original compounds begin to rearrange chemically. This slow maturation process separates oil from gas and solid coal. Oil, or petroleum, is essentially ancient, concentrated marine sunlight. The lighter oil migrates upwards, seeking porous reservoir rocks. An impermeable layer traps the accumulated hydrocarbons beneath it. So, where do the land-based dinosaurs fit into this equation? Land plants contribute significantly, but primarily to coal deposits. The sheer volume of marine plankton dwarfs the terrestrial contribution to liquid fuels. A dinosaur carcass, while large, is mostly bone and protein, not ideal fuel precursors. Rapid decomposition or exposure to oxygen often destroys the necessary organic matter. The kerogen, the precursor to oil and gas, forms best from marine algae. Vast, shallow seas during the Paleozoic and Mesozoic eras were key. Periods of oceanic anoxia, low oxygen, were critical for mass preservation. Tectonic shifts then buried these organic-rich shales deep underground. The depth determines the final product: heavy oil, light oil, or natural gas. A natural gas forms when heat breaks down the kerogen further still. And now that we understand the formation, let's observe the recovery process. Modern extraction techniques allow us to access these ancient energy stores. Precision engineering targets the geological sweet spots of accumulation. Hydraulic techniques create pathways for trapped hydrocarbons to flow. This unlocks the energy density created over hundreds of millions of years. These resources are transported globally to power our infrastructure. When burned, that ancient solar energy is finally released as heat. And the byproduct, carbon dioxide, returns to the atmosphere, completing the cycle. Our reliance on these geological time capsules defines modern civilization. But the timescale of supply clashes with our rate of consumption. B. Scientists are now studying alternative, faster-forming energy sources. I. Storage solutions are crucial for harnessing intermittent, renewable energy flows. On wind and solar energy capture instantaneous atmospheric power. But this returns us to the original source, the sun's constant irradiation. The potential for modern biofuel production mirrors this ancient process. But the efficiency of microorganisms remains an enduring scientific marvel. Our understanding deep Earth geology offers clues about future resource distribution. We drill into history, seeking energy created long before our time. Mapping ancient coastlines helps predict where the richest source rocks lie. But seismic surveys reveal the subtle layering that hides the energy reserves. Sound waves bounce back, creating detailed underground acoustic maps. The key to energy security is understanding this deep geological biography. The dinosaurs roamed the land, but the plankton built the fuel tanks. This ancient flume represented a massive, temporary energy capture event. Ultimately, all this energy originates from a star millions of miles away. The sun fuels the plankton, which feeds our current energy demands. This realization recontextualizes our relationship with geological time. But fossil fuels are not infinite, they are finite snapshots of ancient photosynthesis. The profound power sustaining our world began with the smallest life. Understanding its origin is the first step toward shaping our energy future.